So in order to find the time it takes, the alpha particle takes to move between the plates, we need to find what? Yes, we need to find the acceleration first. How do we find the acceleration? We have a potential difference, we have a distance. F equals ma, yes. Yes, F equals, okay, so F equals ma, E, F equals EQ, EQ on M equals A from both of those. Okay, and we derived that last lesson. So that's how we find the acceleration. We have the charge of the alpha particle. They give us the charge. It's just 2 times the charge of a proton, of course. And we have the mass. They give us that. That's, of course, the mass of 2 protons and 2 neutrons. In fact, there's some mass that this is not the mass of 2 protons and 2 neutrons exactly. It's a little bit different. When we get to nuclear physics, you'll see why, because some matter is energy, the binding energy of that nucleus. Okay, so it's where we get to E equals mc squared, Einstein's famous equation. E equals delta V on D, 200 divided by 0.1 meters. 2,000 volts per meter is the magnitude of our electric field. F equals EQ. Oh no, we'll just go straight to A. A is equal to EQ on M. (2000) times the charge, 2 times the charge of a proton, 3.2 by 10 to the minus 19 coulombs, over the mass, which was 6.644 by 10 to the power of minus 27 kilograms. If you do that calculation, you'll find acceleration equals 1.91 by 10 to the power of 11 meters per second squared, of course. It's an acceleration. No? Oh, I've got the wrong example in front of me, sorry. I use the answers because I don't want to, it takes too long for me to use this calculator, so I just use the answers that the book gives. You guys have to concur, and that's why you need to concur, because I make mistakes. By 10 to the power of 10 meters per second, that's better. Okay. So, time. We have, so this proton is going to accelerate towards the negative plate or away from the positive plate, whichever way you want to look at it, or has a force applied to it by this electric field, F equals EQ. That force associated has associated with it an acceleration. So how do we find the time it takes if we know the acceleration now? Yeah, okay, so we know the distance S, or the displacement S, don't we? S equals the initial velocity multiplied by the time plus half of the acceleration multiplied by the time squared. Ut, the initial velocity is 0, so I'll just cross that out. We're setting the initial velocity as 0. that leaves us with S is 0.1. It's got to traverse 0.1 meters, equals half the acceleration, which was 9.633. Yes, 633 by 10 to the 10 times t squared. And I'm left with t equal to 0.2 on 9.633 by 10 to the 10, all square rooted. And we get a time of 1.44 by 10 to the minus 6 seconds. That sounds reasonable. Think about it. Think about this this alpha particle, very, very low mass. This potential difference is quite large. And so its acceleration is very high. And therefore it takes very short amount of time for it to reach the negative plate. Very, very short amount of time. Two. The final velocity of the alpha particle, v. Okay, quiet please now. Thank you. Shh. We could use v equals u plus at. V squared minus u squared equal 2as. We have this, we have this. This is all fine. This is both fine. I like this one. It's probably a little bit quicker, less confusing. We haven't got any negative signs in there. Initial velocity 0. V equals 9.633 by 10 to the 10 multiplied by 1.44 by 10 to the minus 6. .39 by 10 to the 5 meters per second. It's a good idea for those students that often don't do the calculations while we're working on these to do those calculations. It's good to get used to using your calculator. The amount of times that students have typed in the wrong number and lost a mark because of that, it's very costly. I'll point out also that there's another way to solve this using we call this the energetic approach, or yes, half mv squared. Approach. If you know the work done, then you know the kinetic energy, and you can find the velocity from that. Of course, we are talking in classical physics here. This is a particle of matter, and so these classic formulae work for an alpha particle. I won't go through that. It is in your text. Another problem for you to have a go at now. Here's a different type of problem. One of 3 types that you'll look at today. Here we have please. Here we have two parallel plates again. Distance between them 0.1 meters. Same potential difference, 200 volts. This time we put a proton in and we fire it. We fire it upwards from the negative plate. Of course, it's attracted to the negative plate, so it turns around and comes back down. I don't know whether it reaches the positive plate or not, but it turns around and comes back down. We need to find the force on the proton, the acceleration of the proton, the time before the proton returns to the negative plate, and this was a subject of deliberation in the last class, because we said, okay, the time the proton takes to return to the negative plate, I read that as where it gets to the top of its path, so that time there, not the entire time for its path. Of course, it's not going to do this. It's going to go straight up and come straight back down. I'll just draw that to make it easy to see. I say it's half the time there, okay, but it doesn't matter. We'll look at both. And then the distance. So this distance, this vertical distance that the proton moves, whether it reaches the positive plate or not. Have a go at this. We'll come back to it. F equals EQ. Delta V is 200. D is 10 centimeters. (2,000 volts per meter). I'll come over here. F equals 2,000 times the charge of a proton, which is 1.6 by 10 to the minus 19 coulombs. Of course, 3.2. 2 times 1.6 is 3.2. We multiply that minus 19 by 1,000, we get to minus 16 newtons. And one thing that this problem doesn't show you, it asks you to find the force, and of course, you have to state the direction. Towards the negative plate. You could say, yeah, so you could say downward. Yeah, that would be fine. I'm going to say more specifically towards the negative plate. Downward is fine. In fact, I think in your text, they do this. They put a little minus sign in it, and they say that downwards is negative, is in the negative direction. Okay. Question 2. The acceleration, A equals EQ on M, which is equal to F on M, isn't it? 3.2 by 10 to the minus 16 on the mass of a proton, which is 1.673 by 10 to the minus 27 kilograms. 1.91. I'm going to leave a space there at the front. Oops. 1.91 by 10 to the 11 meters per second acceleration in the negative direction, in the same direction, downward. Time it takes. What have we got? So we've got acceleration. We got the final initial velocity, yes, and we've got the final velocity, because the final velocity is this point here, isn't it? I'm gonna say v equals 0, so that's kind of like the final velocity in this case. Okay, so U equal to 1.0 by 10 to the 5 meters per second, 100,000 meters per second. V equal to 0, top of its path. Top of the path. V equals U. I'm going to state my formula first. It helps us to read what you're doing. V equals U plus AT. We're left with 0 equals 1 10 to the 5. Now, why have I done this? Yeah, that's okay. I'm just looking at half the path. A is minus T minus 1.0 by 10 to the 5 over minus 1.91 by 10 to the 11. Oops, should put an equal sign there. And we get 5.23 by 10 to the minus 7 seconds. Now, I've just calculated, and this is the way I always do it. I've calculated half of that trajectory, that path, haven't I? The time that it takes. And we debated this because I just stopped at that and moved on to the next question. The last class flipped out because I hadn't said, oh, well, you got to multiply it by 2. Time before the proton returns to the negative plate. And that, I read it as the time before it turns around and comes back to the negative plate, but it actually means the whole path. Okay, so for the entire path, up and down, it's 2 times 5.23 by 10 to the minus 7 seconds. I'll leave it at that. 4. What does 4 ask? The distance the proton moves upwards in the space between the plates. So this displacement here, what is that displacement? And I did this, S equals now, if we have the acceleration that it experiences and we have the time, then we can solve this. And I said this, imagine the proton does this, it moves up, it doesn't do this nice parabola. What it does is go straight up and down, as we all know. We know that at this point here, top of its path, V equals 0. But I'm going to say U equals U. This is logical to me because I'm going to say, well, I want to know this part of the path, just this part of the path here. That also gives me the height, doesn't it? So then it's not so bad. S equals this gets cancelled out. Please. Half. Yes. Yeah, so in this case, yeah, it's going to set up the acceleration as negative, but I'm just going to say the magnitude of that acceleration. Yes. Scroll up a little bit. Where? Yeah, so we're looking at this displacement here, aren't we? So the top of its path to back down. The question might ask, please. The question might ask in the test, does the proton reach the positive plate? Okay, so let's have a look. Yes. Uh, yes, if I use this number, but I'm going to use this number here. Yeah. Follow me and watch this later, perhaps. Okay, so I'm just going to put in my acceleration, the magnitude of the acceleration, which was this number, wasn't it? 2 times 1.91 by 10 to the 11 multiplied by the time squared 5.23 by 10 to the minus 7. Don't forget your squared. Classic mistake to make. And the book says 2.61 by 10 to the minus 2 meters, which equals centimeters. It does not reach the positive plate. Because that's 10 centimeters, of course. You could have used this. You could have used quite easily b squared minus u squared equals 2as, and you could have done this part of the path here using 100,000 here, and u is equal to 100,000, v equal to 0. You still get the same thing. Still get the same value. Yeah. So this is the confusing part. I'm saying this. I'm calculating the height by this part of the path on the way back down. It's the same thing. It's a way that I like to do it. It's the most logical way for me. And I know that's not going to be true of you guys, so I just want you to be aware of the other way to do it. Um, Not everybody will feel the same way that I do. I see. What did you get? And that's with this, Travis? 100,000. Yep. Yes. In that case, yeah, that's right. So imagine here u equal to 100,000. We're saying that that's positive. We're saying that upwards is positive. The acceleration must be negative. Yes. And I'll state that here for this. You guys are sounding good now. You sound like physicists. That's good.